Hello everyone, welcome to Chemistry Guide. In this lecture, I will discuss about chemical equations and how to balance the chemical equations. Before seeing how to balance the chemical equations and how to write the chemical equations, we will see what is meant by the physical change and chemical change. So, a physical change, in what happens in physical change is the chemical identity of the substance will remain same, even the physical state changes. That is, if you take the example of ice, if we supply heat to the ice, it will be converted into the water. That is, here the physical state is getting changed from solid to liquid, but the composition, chemical composition, is H2O in both the cases. This is known as the physical change. And what happens in chemical change is the chemical identity of the substance will change. So if we take the magnesium ribbon and if we burn that, we will get a white powder called the magnesium oxide. That is, here magnesium in the presence of oxygen is getting converted into magnesium oxide. That is, the chemical formula is getting changed, and this is known as the chemical change. So in chemical change, the chemical identity of the substance changes, whereas in physical change, the physical state may be changed but the chemical identity will remain same. Now we will see chemical reaction. Whenever a chemical change occurs, we can say that chemical reaction has taken place. That is, whenever we are getting a chemical change, as in the previous case, when we burned the magnesium ribbon, in oxygen we have got magnesium oxide. We will say that chemical reaction has taken place in that case. So we can, by doing the following observations, we can say whether a chemical reaction has taken place or not. Change in state, change in color, evolution of a gas, change in temperature. If we observe any of these things when we perform some change or something, we will say that chemical reaction has taken place. Next, we will see how to write the chemical equation. The chemical reaction, which is expressed by using chemical formula of reactants and products, is called chemical equation. That is, we are saying that in words we will say that when we burn the magnesium ribbon, we will say that by burning magnesium ribbon in the presence of oxygen, we are getting magnesium oxide. So in the form of sentence, we will say like that. So to make it short, we will use symbols and words and we will write it in the form of the equation. So here, if we see that by combining magnesium with oxygen, we are getting magnesium oxide. Here magnesium we will write as magnesium plus oxygen will give magnesium oxide. So here by using magnesium and oxygen, we are getting magnesium oxide. This magnesium and oxygen which we have used are known as the reactants, and the thing which we are getting after the reaction has taken place is known as the product. So here we will see the definitions of the reactants and products. Reactants are those substances that undergo chemical change in the reaction. In the previous case, magnesium is undergoing change in the presence of oxygen. So we will say that magnesium and oxygen are the reactants, and we are getting magnesium oxide as the product, so it will be the product. So the definition of product is the new substances that are formed in the reaction are known as the products. So example, if you take that example, here magnesium and oxygen are reactants and magnesium oxide is the product. Next, we are writing like magnesium plus oxygen is giving magnesium oxide, we are writing in words. Now we can also write that by using the symbols or chemical formula of that. If you see, chemical formula of magnesium is Mg and for oxygen it is O2 and magnesium oxide it is MgO. So we will write that chemical equation as Mg plus O2 will give rise to MgO. So we will see, we have already that means in your previous classes you may be aware of the law of conservation of mass. Here again, in order to understand better what is meant by the unbalanced equations and balanced equations, we will take a short review of that law of conservation of mass. It states that mass can neither be created nor be destroyed in a chemical reaction. That is, the mass of the reaction before the reaction has taken place should be equal to the mass of the constituents present in that after the reaction has taken place. That is, the number of atoms of each element present in the reactants as well as the products should be same. So unbalanced skeletal chemical equation. Now we have seen that we are writing chemical equation. Those chemical equations may be balanced or unbalanced. So we will check whether the chemical equation are unbalanced or balanced. Here if you take the example of N2 plus H2 giving rise to NH3, that is formation of ammonia. Here in reactant side we have 2 nitrogen and 2 hydrogen. But in product side we have only 1 nitrogen and 3 hydrogen. That is, the number of nitrogen on reactants is not equal to that of the products, and same the number of hydrogen in case of reactants is not equal to that of the products. So here they are not balanced, that is the number of N atoms and the number of H atoms as well. So we will say that equation as the unbalanced or skeletal chemical equation. If you see that here we are not having the same number on the reactants and product side, that is, it is not following the law of conservation of mass. But we are saying that reactants and products, whatever it may be in the chemical reaction, they have to follow the law of conservation of mass. So there is a need for us to balance the chemical equation. In order to make sure that law of conservation of mass is obeyed, we will balance the chemical equations. So this is the drawback of skeletal chemical equation. It is not following the law of conservation of mass. So in order to follow that, we will use the balanced chemical equation. So we have to balance the unbalanced chemical equation. Now we will see what is meant by balanced chemical equation. So an chemical equation is said to be a balanced chemical equation when the total number of atoms of a particular element is same on both the sides, that is on reactants as well as product side. That is, if 3n are there on reactant side and if 3n are there on product side as well, then will be a balanced equation. But if the number of atoms are different on the reactants and product side, then it is not a balanced equation, as we have seen in our previous slide. So now we will see how to check whether the given chemical equation is balanced or not. Here we are having 3, that is 4 are there, Zn, H, S, O. So we will count them separately. Here on the reactant side we have only 1 Zn. In product side also we have 1 Zn. So both the number of atoms of Zn present on both the sides are same. So next we will check for H. On reactant side we have 2 hydrogen. If we check on the product side, we have 2 hydrogen as well. So with respect to H also it is balanced. So now we will see with respect to S. Here on reactant side we have 1 S and on product side as well we have 1 S. So on both the sides we are having only S. So with respect to S also both the sides are balanced. Now with respect to O, we are having 4O on reactant and as well as 4O on product. So with respect to O also it is balanced. So with respect to all the atoms present in the chemical reaction, it is balanced. So we will say that this chemical equation is balanced. Now we will see how to balance the chemical equation. So in order to see how to balance the chemical equation, we will take the example of Fe plus H2O gives rise to Fe3O4 plus H2. See, here first we will see the different atoms that are present. We will make like a table. We will make here the different atoms that are present in this reaction are Fe, H and O. So we will write the number of Fe present in reactant side and as well as product side in the table. So if we see on reactant side we have 1 Fe and on product side we have 3 Fe. So we will write it there. And H also, on reactant we have 2H and on product also we have 2H. And if we see O, on reactant we have 1 O but on product we have 4 O. First we will make a table like this. Next step we will choose, first we can choose any atom to balance, but we will get more accurate results if we choose the compound that contains the maximum number of atoms. So if we see in our previous example, we are having maximum number of atoms in Fe3O4, and in that compound we will choose that element or atom which is having more number of atoms. So if we see Fe, there are 3 Fe atoms and 4 oxygen atoms. So in that Fe3O4 compound we will take oxygen atoms to balance the chemical equation. So now we will see, if we see in the reactant side we have 1 oxygen, but in product side we have 4 oxygen. So to make it 4 on the reactant side as well, we will multiply that H2O with 4. So now the partly balanced chemical equations will become Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Now we have just balanced O atoms. Now Fe and H atoms are still left and they are not balanced. Now in between these two we can take anything. So here if we take hydrogen, here on LHS we have 8 hydrogen, But on RHS, that is on products, we have 8H2 as well. Sorry, only 2 hydrogen atoms are there. So we have 8 on reactant and 2 on product. So in order to make the hydrogen atoms present on the product side also equal to 8, we will multiply that H2 with 4. So if we multiply with 4 here, we will get 8H on products as well as 8H on reactant. So now our chemical equation is balanced with respect to Fe and with respect to H, but it is not balanced with respect to O, and with respect to H it is balanced, but with respect to Fe it is not balanced. So now we will see how to balance that with respect to Fe. So if we see that on LHS we have only one Fe, but on RHS we have 3 Fe. So therefore to balance that we have to multiply the Fe that is present on the LHS with 3. So if we multiply with it with 3, we will get 3 Fe on reactants as well as 3 Fe on product side. So now by doing all these things, we will get the chemical equation as 3Fe plus 4H2 giving rise to Fe3O4 plus 4H2. Now we will check whether the chemical equations what we have done is correct or not. Here if we see on the reactant side we have 3Fe. If we check on the product we have 3Fe. And if we check we have 8 hydrogen on reactant as well as 8 on product. And if we see O, we have 4 on reactant as well as 4 on product. So we will say that this chemical equation is balanced. Now here we have just mentioned what is the reactants, what are the products, and we have learned how to balance that. So to make balanced chemical equation more effective, we will mention the states of the elements in which they are present. So if you see the previous example, Fe will be present in the form of a solid, and H2O, here H2O is taken as a form of steam. So we will mention the state of H2 as gas, and Fe3O4 is a solid and H2 is a gas. So solid we will write in brackets as S, and for gas we will write in brackets as G, and if it is a liquid we will mention that in brackets as L. And if it is aqueous, that is if the element is present as a solution in water, we will write that as aqueous. If the element or compound, whatever it may be, if it is present in the form of solution in water, we will write aqueous. For that we will use AQ in brackets. So sometimes we will mention the reaction conditions also, that is at what temperature that reaction has taken place, or at what pressure that reaction has taken place, or what catalyst we have used in order to make that reaction feasible. All these things also we will mention, and the things which we have used, that is temperature, pressure or catalyst, we will mention. Here we are seeing arrow, above that arrow or below that arrow we will mention those things. I hope you have understood today's lecture. If you have any doubts, please feel free to type in the comment box, and you can get the PDF from the description box. Thank you for watching this.